Okay, so in the previous video, we learned how to calculate the variance. Let me relate what we learned, how to calculate the variance to what we learned in chapter 3. So in chapter 3, we learned the transformation of a random variable, right? So for example, our information is about x, but we are interested in another random variable y. Then it is called transformation. And then we learned how to calculate, say, expectation of y using the transformed information. This is exactly what we have done for the variance. For the variance, what we have done is, say, the original variable is x, but we are not interested in the expected value of x. We transform x into x minus mean, which is deviation, and then we transform the deviation into squared deviation, right? And then this is the new random variable we are interested in, so we are calculating its expectation, that is variance of x. Okay, so I want you to see the structure of the logic. It is just a transformation of the random variable, and variance is just one variant of average. Okay, and also when we learned how to calculate the mean, we considered two different formats. One is when you have raw data, right? You just have numbers, like say on the earlier example, we have 4 numbers about Honolulu temperatures, and you can imagine like thousands, millions of numbers on Excel file. So from there, you can calculate the mean and you can calculate the variance, right? But especially for variance, we have to worry about population variance formula and sample variance formula. There are two different conventions to calculate the variance from raw data. But also in the previous chapter, we learned another format, that is probability distribution table, right? Instead of the full data, original raw data, we may have just summarized probability table for each outcome, right? In this case, this is easier, like probability weighted outcome, and then sum. That's how we calculated the mean. So the reason why I'm explaining this is what we learned in the previous video is these cases when you have just raw data. However, it does not apply when you have probability distribution table. That's what we are going to consider from this video. So for example, we are going to consider another example. So we are going to consider a probability distribution for a financial asset, right? Simply, I'll consider 3 possibilities. It may return minus $10, or it may return nothing, or it may return $20. So loss or gain. And the probabilities are given like this, 20%, 40, and 40%. Okay, so we would like to calculate the variance. Everything is the same if you understand what we are doing. So this is, oh yeah, I erased it. I'm going to calculate the mean, and I'm going to calculate deviation and squared deviation, and then mean of square deviations. Okay, I explained this is just a transformation of the original variable, and this is calculating just another mean of the transformed random variable. That's what we are going to do. Let's do. The first step is to calculate the mean. And outcome, these are outcomes and these are probabilities. So we are going to calculate probability weighted outcomes like this. So multiply minus 10 to 0.2, that's minus 2. 0 to 0.4, 0. Plus 20 times 0.4, that's plus 8. So sum of these three probability weighted outcomes equals 6. So the mean is 6. So the expected return from this investment is $6, simply speaking, or you can think like 6% or whatever. The mean is 6. Okay, then the next step is to calculate the deviations. Simple. We have outcomes here and the mean was 6. Okay, so mean was 6. So if you have minus 10, that is 16 below the mean, right? And if you get 0, that is 6 below the mean, and plus 20 is 14 above the mean. So these are deviations, simply subtracting the mean from the outcomes. Of course, we do not use the probability yet. And next, we are going to square those deviations, right? We calculated deviations in the previous slide. So then we are going to calculate square deviations now by taking squares, right? 16 squared is 256, and 6 times 6 is 36, and 14 times 14 is 196. So 3 new outcomes. So look at this. This was the original outcome, but we transform the original outcome into a new outcome, right? This is what we wanted. What we want is the distance, not the absolute gain or loss. Okay, and then up to here, until we calculate the square deviations, we did not use the probabilities, but now we are going to. So this probability also corresponds to the new outcomes because they are just one-to-one, same thing, just changing the numbers. So again, we get the square deviations and the same probabilities. We are going to calculate the mean of squared deviations for variance. That's what we are going to calculate. So then you know how to do it. This is outcome, this is probability. So calculate the weighted outcome using the new outcome, okay? So this is the outcome we are interested in. So multiply 255 to 0.2, we get this. And 36 to 0.4, we get this. And 196 to 0.4, we get this. So if you sum these three probability weighted outcomes, you get 144. That is the variance. Okay. So this is a brief summary of how we calculate the variance from a probability distribution table. Remember, so depending on the format of the information, you have to use different methods here, but the idea is the same. First, you calculate the mean and calculate the deviation and calculate the squared deviations and multiply probability and then sum the probability weighted square deviations. So these two steps calculate the mean of squared deviations. So, and also in here, in this case, when the probabilities are given, there is no population or sample formula. There is no difference, right? Because probabilities are given, and we don't have sample size. We don't know the sample size in this case, so we are not going to use the distinction between population and sample. Okay, so then I'm going to stop the video here, but I will, like at the beginning of the next video, I will slightly change the numerical example. Suppose that you pay $1 fee upfront to make this investment. Okay, so like minus 10 becomes minus 11, 0 becomes minus 1, 20 becomes 19. So including those fee, what is the net gain and loss are given like this. These are also another outcome transformed from the original variable. And you try to calculate the variance using the method that I demonstrated earlier. So, and then watch the next video.